Grignard. So Ariel is from Israel, Arnaud's from Lyon, France. Ariel is an architect. Arnaud is a computer scientist. He specializes in complex systems, modeling and information visualization. He's a specialist in agent-based modeling. Many of the visualizations, simulations that you'll see here at Andorra CityScope were done by Arnaud, so welcome.
Hi everyone. So as Kent mentioned, I am a computer scientist. So what I will go more in detail on the presentation that Ariel did, and I will kind of show you the model behind the agent as soon as we can start the PechaKucha. So I will focus on what Kent mentioned. I will explain you what are the agent-based modeling. So I will explain you a bit more in detail what is going on this table. This one is the one we have in Media Lab, but tomorrow you will be able to see the same model running on Andorra. So first of all, I want to give some theoretical definition about what is a complex system. So what we call a complex system is a number of heterogeneous interactive components that can exhibit emerging behaviors in time and space. So complex system is a domain that is now used since, let's say, 30 or 20 years, and it's a formalism that is used in many different domains, such as biology, economy, sociology, and it fits very well to study a city, because actually a city is one of the kind of perfect complex system. So it's used in many domains, and it's also multidisciplinary, or as Kent would say, maybe antidisciplinary, but multidisciplinary because you have many ways to study that kind of model. You can use a microscope if you are a biologist, you can use a paper if you are a mathematician writing equation, and I will show you how you study that kind of model using a computer and then using a simulation. So basically, when you use a simulation, you do an experimentation on a real system. So from your real system, you build a model, you run the simulation, you can execute your model, and then you can answer to a specific question to your model. So we will see together how to implement that. As I said, so agent-based modeling is one methodology, but you have many ways to do simulation. You have the micro simulation, system dynamics. As I said, you can just have a simple equation. And among those different meta models, there is one that is called agent-based modeling. So maybe during this day, you will see those moving dots. Consider them as agent. So agent-based modeling, the main principle is to use an individual representation to produce a global understanding on a phenomenon. So here, if you want to reproduce this model, you will define every individual, and then you will be able to run it. What is important to keep in mind also is that that kind of technology can be used to many different applications with many different spatial and temporal scale. You want to be interested on pedestrian dynamic, on disease spreading, on something at the planet scale. So it's very flexible. So one case study that I will show you more in detail how to study that kind of system. Let's focus on the mobility approach, where typically you have lots of different heterogeneous objects, truck, car, people, bicycle, so many people interacting together, and then you want to understand what's going on. So this is a very simple approach where each car is an agent. They have just two simple rules. If there is a car in front of me, I will slow down, and if there is no car, I will speed up. And you see that all those guys, they are doing the same behavior, but you can start to reproduce a realistic traffic congestion. So the following visualization that you will see is use a dedicated agent-based software called Gamma. It's an open source software that we use a lot at MIT. It's developed also in France. And this is something that will help you to build your model. So you will see a lot this model. So it's, I think, one of the most established model that here we modelize the the tourism pattern, so you will see it in reality. It's a typical agent-based modeling where you have this agent that represents people, and then on top of that, we can represent different flow. You will see it more in detail. Now I want to explain you really step by step how the model that is running on this model is implemented. So this is what we call the VolP model. So it's a physical table that we have at the Media Lab. This is our prototype, and then we deploy it in different cities. So the way it works, it's very simple. One agent, he would have a place where he lives, a place where he works. So here is the MIT campus. He will go to work, then he will go to eat in one of the amenities, going back to work, then going back to dinner, and finally going home. So kind of boring life, but that's how it is. So you repeat that for here for 10 people, okay? And then as soon as you have the right demographic data, you are able to reproduce it at the level of the city. So this is the model that we are able to build and run on our table with GIS data and demographic data. And this is after what you can have. One of the main strengths of the agent-based modeling is that you can see the interaction between people. So you can start to have a feeling on what are the potential interaction. So here, you see the different interaction between people during the day. So we are very interested in our group to understand how a city can be creative, so how you can enhance the interaction. Using that kind of model, you can do something even more large scale. That's a work we have been doing with BCG, where we apply those models on a very specific area of Boston with different kind of mobility. So we have been running this model on, on the Boston city center. And then you can run it with different scenarios. So here is a scenario where you have public transit, private car, self-driving car. You run this simulation, and then after a few iterations, you are able to have some results about the impact of those configurations. So you can have impact on the number of vehicles, the distance travel. This percentage is always a comparison between the existing. So this is like, let's see how Boston would behave if we have this configuration. And then you are able to change it and to adjust in order to see if you need more bus, more self-driving car, or that kind of effect. So this is a project that we have been doing in Boston. And to finish, as we said, we want to deploy those models in many, many cities. Right now, the one that I described here in VolP is also running. So in the Andorra CityScope, we are also doing a version in Tonji and in Alto. So as a research scientist, my goal is to have something generic that we do it in the Media Lab, and then we apply it in different cities. So thank you for listening.